First and special thing with Snowflake is again it's cloud-based database, data warehouse. So what's a special? Already we have so many databases available in cloud. Like if you take if you take Azure, it has its own database, and AWS it has its own database. So the thing is that, but the special with Snowflake is Snowflake is offered as a software as a service in three different cloud providers. It's available in AWS, available in GCP, and Azure also. So, in whichever cloud platform we are familiar, we can avail this Snowflake from that particular cloud platform. See, for example, nowadays, right, if my project, my client is having the data in particularly in AWS, right? So if my database data warehouse is in different cloud platform, there may be some synchronization issue, some kind of things, right? But in Snowflake, since it is available in three different platforms, right? So if your data, if the client data is available in, we can avail the Snowflake from AWS itself. So there is no need of the cross-platform issues. I mean, no issues will come, right? So that one special with Snowflake. And another thing is, since it is offered as uh, cloud service, right? So we don't need to take care of any hardware and any installation, any configurations, nothing. We don't need to worry about these configurations and installation, anything, because this will be even upgradation also. Because if you install any, for example, if you take SQL Server, right? So you are purchasing the software, and if you want to install into your machine, the first and foremost thing you have to check is your system configuration. You should have enough space in your memory. I mean, in laptop or desktop. So these things we have to take care. But since it is offered as a cloud service, we don't need to worry about these kind of things. And even sometimes the upgradation also. So whenever the software is getting upgraded, we have to do it by manually. But here, since it is cloud, right? So everything the admin will take care, right? So as a developer, we don't need to think about this, I mean, installation and configuration and all. And next thing is virtual compute. So if you see the architecture, the Snowflake, so many features of Snowflake is offered because of the special architecture of the Snowflake, right? So what is special with the architecture is it is having three different layers, right? So database storage, query processing, and cloud service layer. So database storage, as the name depicts, it is responsible for storing your data physically. So it's like nothing but your normal disk. And the second layer is query processing layer, where we have a lot of virtual warehouses. This is not your data warehouse, right? So this is not data warehouse means collection of databases, right? But here virtual warehouse means collection of processes, right? So here every virtual warehouse will have the collection of processor which is responsible for executing your query, right? Then coming to the top layer, cloud service layer, this is responsible for doing all this optimization and authentication, authorization kind of things, right? So whenever the query is submitted, all the users are directly interact with this cloud service layers. Okay, so for example, if I'm writing a query and I'm pressing the run button, the query will be submitted to this cloud service layer, right? Then it will be optimized by the optimizer, and the metadata manager will extract the metadata from the query, and that data will get stored here. Then once all the things are done, that query will be submitted to the processor, means your virtual warehouse. It will process your query, and it takes the data from data warehouse, I mean the storage, and the data taken from the storage will come to this layer again, right? So here there will be some cache, local cache. The name of the cache is local cache. So the data is getting stored in this local cache, right? From there it reaches this cloud service. Again, in this cloud service also we have a result cache, right? I can show you the things. So like this. So the data taken from the storage, this disk, will be stored in the local cache, and again from that it moves to this result cache. Okay, so what is the special with this cache, and what is the feature we'll get because of this caches, right? So as already said, Snowflake is a cloud service, right? So whenever you are availing a cloud service, as a user, I need to think of two things, because uh, this is actually the paid one, right? So whenever I'm availing a cloud service, for what are the things that we are going to pay is, one is how much storage you are occupying, and second thing is how much computing you are getting. Okay, so you are going to pay for two things. One is your storage, another one is for computing. Okay, so Snowflake is designed. Snowflake actually has designed its architecture, right, to reduce your storage cost and the computing cost. So actually, all these catches are used to reduce the computing cost, right? So how it is used is, so how the catches are used for reducing the computing cost is, when the query is submitted for first time, right? So as I already said, it comes here, it is executed by this warehouse, and the data is taken, and now the result of that query is available in this cache, local cache, and the result cache also, right? So when you are trying to execute the same query without doing any changes, when the query is submitted for second time, right? So already that metadata is available here, right? So whenever the query is submitted, first and foremost thing is the metadata manager will check whether the query is already executed in the past or not. Okay, right? So if the query was already executed in the past, right? So what happens is it will go and check whether the result of that query is available in the result cache, right? It will check for it. If the result is available in the result cache, it takes the result from that cache itself and it will be returned back to the user, right? It will not execute. You can understand, because of this result cache, the execution of second time execution of the same query is getting cut off, right? Due to that, the computing cost also is getting reduced. So how long the result will be available in the caches is, in the result cache, I told you there are two caches. One is the local cache, which is available in the query processing layer, and the second thing is result cache, right, which is available in the cloud service. Okay, so the result cache can hold the result for 24 hours. Okay, so if I'm executing a query, the result of that particular query will be available, right, for next 24 hours in the result cache. Okay, so within that 24 hours, if you are executing the same query, that query will not get executed, but instead of that, the result will be taken from the result cache itself. Okay, so by this way, the computing cost is reduced. Okay, so coming to the storage cost, right? So storage cost means how much space we are using, right, to store our data, right? So to reduce that storage cost, Snowflake stores all the data in a compressed format. So whenever you are loading any data into a table in Snowflake, right, in the background, the Snowflake will compress your data, right? A lot of compression method algorithms are there, right? So by using that, Snowflake will compress your data and then it will store that compressed data into your disk, so that the storage cost also it is getting reduced. Because as I already told you, right, whenever we are going and availing a service from cloud, we have to take care of two things. We have to mind two things. One is storage cost and the computing cost. So both the things, Snowflake is offering so many support to reduce this cost. Okay, so this is one special with this architecture. And second thing is, I told you, right, this metadata manager, lot many features of Snowflake works based on this metadata manager. Okay, so say for example, I told you, right, how can the Snowflake can understand whether the queries executed in the past, I mean, the query is executed already or not, right? Because it stores when whatever happens in your Snowflake, right? It takes the metadata, and the data metadata is getting stored in the history table. Okay, see, so that Snowflake is offering so many features, right? Other than this, we have a micro partition concept, right? So, what is micro partition is, if you are having a table, right? You want to store this table into the database. If you are storing it in other databases, right? So the whole table is stored as a single object. Okay, right? But in Snowflake, what happens is, right? This table will get partitioned uh, into small blocks, right? So then it stores that blocks into a storage. Instead of storing whole table as a single object, it divides your table into small blocks, and that blocks get stored. Okay. So what is a special with this feature is, whenever you want to fetch any data from database, right? You know well, right? See, you are writing a select statement, select star from a demo table. Okay. So what happens is, you know well, right? That whole table from database usually comes to this place, and then the fetching of data happens, right? So this is what happening in the other databases, but in Snowflake, right? See, for example, I'm writing a query, select start from demo, where id is equal to 1. Okay, and imagine, sorry, type is equal to 4. I'm writing, you just imagine the table name is demo. So select start from demo where type is equal to 4. So you know well, the type 4 record is available here, right? So now this particular record is available in this partition only. Okay, right? So what Snowflake is doing is, with the help of the metadata information, it finds where actually the record is available in which micro partition. Okay, so it can understand the particular record is available in this partition, so it will load only this micro partition, right, to the this layer, main layer, instead of loading the whole table, so that the loading time is getting reduced. Okay, right? So this is one special with micro partition. How this micro partition is working, that and all, it is a deep, see, every time, right? So it is actually storing some metadata information about your records, right? So that is the one feature. Second thing is, it offers support to the semi-structure also, right? It can, in Snowflake, we can handle um, your JSON, XML, so kind of semi-structured data also, right? So there is a data type called variant, right? So this data type can be used to handle your semi-structured data. So even we can handle ParQ. So this type of files also can be handled. Next is staging. So this is very special thing. Whenever you are loading a data into a table, right? So uh, I can show you. So this is the concept of staging, right? So here is the table, and you want to data. I mean, you want to load a data which is available in some XML. For example, I'm telling a CSV file. Okay, so you have the data in a CSV file, and you want to load that data into a table. Okay, so what happens is, you know, the concept of staging is working here. So we have two types of staging. I mean, internal staging and external staging. So internal staging means the staging area which is available inside Snowflake itself. Okay. External staging means, you can understand, right? The storage area which is available outside Snowflake. So outside Snowflake means where it is in your corresponding cloud platform. It may be either AWS, GCP, or Azure. Okay. So what's the special with this staging area is, you know, well, right? If you're directly loading your data into a table without using any staging, there may be a chance of losing your data, right? So to avoid that, what Snowflake is suggesting is, first you have to move your file into a staging, maybe either internal or external. Then from staging area, the data can be loaded. So due to that, the data loss can be avoided. So next important and special with Snowflake is time travel. What is the time travel is? Imagine I'm having a demo table. Uh, so I'm having a demo table with 5 records. Okay. So with ID 1, for your understanding. So ID 1, 2, 3, 4, 5. So at the time, maybe you just imagine 5:01 a.m. Okay. So then what I'm doing is I'm deleting the record with ID 1 at 5:03 a.m. Okay. So after deleting the record with ID 1, right, in future, maybe at 5 a.m., I want to access this particular record which I have deleted just now. Okay, so what I can do is I can avoid the concept of time travel, so which allows you to travel to your past, right? Your past time and access your data or the record which was available in that particular time. So that is what time travel. Hope you understand, right? So after the record is deleted, still I can able to access that record with the help of this time travel. I can travel back to this particular time and I can access this record. Okay, so that's also possible. And the other thing is we have a concept called undrop, right? You know the purpose of drop command. So this is actually used for dropping the object, right? Maybe your table kind of things, right? So if the table is dropped, right? Drop table demo, for example, I'm doing it, right? Still, I can revoke that table. I mean, I can get back my table even after I'm dropping the table, right? With the help of this undrop. So I can just use undrop table. Okay. So all these things are possible with the help of this time travel. So that is one special, right? How it is possible is there is a concept called retention period. Okay. So whenever you are creating a table, right? So every table is having its own. I mean, we can fix some retention period. So how long I want this table to exist, right? Even after I delete the table. Okay, so the maximum retention period is 90 days, right? If you don't want to retain the table, right, even you can set that retention period to 0, right? So if you are setting the retention period to 0, once the table is dropped, that's all. You cannot undrop it. Okay, so all these things are possible with the help of this time travel. So next is fail safe. It is also again, um, uh, see, for example, I have deleted or maybe accidentally my data is missed, right? So in that case, what happens is, for example, I'm just telling you, this demo table retention period is, I have only 5 days. I have set it to 5 days. Okay. And I drop the table. On the 6th day, I want this table to be get back to my Snowflake again. So what I can do is, still I can get the help from the Snowflake support team. Okay. So I can um, directly reach out to the Snowflake support team, and then I can get back my tables, which was deleted even after the retention period. Okay, so the difference with the time travel and fail safe is this time travel is working till your retention period gets over. Okay, if the retention period is 5 days, right, until the fifth day is getting over, I can able to get back my objects from my side itself. Okay, once the retention period is over, right, then I cannot do it by myself, but still I can get back with the help of the Snowflake supporting. Okay, so that feature also available with Snowflake. So again, all these things are working with the help of some metadata, right? So there is some fail-safe period. How long Snowflake? I mean, even the retention period is over. After the retention period, also how long the data has to be maintained. So that period also fixed by this fail-safe period. Okay. The next special feature is data sharing. So right, we are working for some important clients, right? So imagine we have two developers, access, granting access, right? So it works with that, right? So we have two developers, right? So developer one is having full access. Okay, so see, for example, my Snowflake is having 5 tables, or yeah, 5 tables, right? So now I don't want this developer to have access on all the 5 tables. I want this developer to have access only on 2 or 3 tables. Okay, right? And that too only read access. Right, the developer two should not. I should not. I mean, the developer two should not allow to do some changes on the tables. Okay, so in that case, what the data owner can do is he can create a share. Okay, there is a concept called share. So we can create a share on this database or particular table, and that can be shared with developer two. So now what the developer can do is, so this developer two can use the share to see the data into the particular table. He can just use a select statement. He cannot do any insertion, deletion. He cannot do any modification with the tables. Okay. So this improves, this gives more security for my table, my data. Okay. So that's a special with this data sharing. Okay. More specifically, if you want to say, so I did my survey, right? For example, this COVID-19, right? So I did some survey. I have collected a data on this COVID-19, right? And I want to share the data with others, but others should not do any modification. They can just use it. So in that case, what can I do is I can just take a share on my database and I can share it with the people who want that. Okay, so this ensures the security and authentication also. The next is zero copy clone, right? This is also special. There is a concept called cloning, right? So already there is a database, right? For example, there is a demo database, so which has around some tables, right? And you want to have an exact copy of the database, right? I want to create a demo one database which has the exact copy of this demo. So in that case, we will use clone concept. So what is the special with clone in Snowflake is it is zero copy clone. What is that zero copy is? So what is that zero copy is? This is demo. Just imagine this is demo and this is demo one. Okay, right? So when you're creating a clone, actually your data will not be copied. Okay, right? Instead of copying the data, instead of cloning the data, what happens is it create a reference, new reference. Okay, so this is demo, this is demo one. Both will point to the same set of data, right? Physically. So whenever you're giving select start from demo and select start from demo one, both will point to the same set, same physical disk where actually the data is available. Okay, so when you are doing any changes or when you are doing any modification on the data, then only the actual copy of data is happening. So until you are doing any changes, both of your databases will point to the same data, right? Same copy of data. Okay, but when you start doing any changes, then Snowflake actually take a copy and it will store into a physical another physical disk, so that the storage cost is reduced, right? Again, it is not copying the whole data, right? When you are doing the modification, right? In which particular micro partition you are doing the changes, that micro partition alone is getting copied. Okay, so for example, I think that picture I have missed, so I try to explain here itself. So you have demo one. Okay, so both will point to same set of data in the database. Okay, so when you are doing some changes, like you are inserting, when you write insert statement on demo one, on that time, what happens is, right? It in which micro partition you are doing the changes, right? So that micro partition alone, it is getting copied and it is stored as demo db1. Okay, now demo one will point to both db and db1, because db is having, see for example, you have 10 micro partition here. Hope you understand what is micro partition, right? Right, you are doing changes on the 10th micro partition. So what happens is, both demo and demo 1 will point to the same db for all 9 micro partitions. Okay, for 10th one alone, demo will point to db for 10th micro partition, and demo 1 will point to the db1 for 10th partition. You understand? So db is having 10 micro partition, right? You just imagine db means the remote disk. Okay, having 10 micro partition. So we have two things, demo and demo 1, right? So initially both the reference will point to the same database and same remote disk. Okay, then you are doing some changes, right? What you are doing is you are inserting some new record into demo 1. Okay, so that record is getting inserted on the 10th micro partition. So now what happens, for remaining 9 micro partition, your demo and demo 1 will have the same reference. But for 10th micro partition, the 10th micro partition is getting deferred for demo and demo 1. No? That's what, for different reference will be created for the 10th micro partition for demo and demo 1. So you can see, right? If you take other databases, right, whenever you are doing a cloning, whenever you do the cloning, right, so it copies the entire database, right? It takes the entire database so that this points to one database and the demo one points to other database.
So the use case for this one is just the migration, right? Migration of data and database migrations. When there is promotion of data from one environment to other environment, you'll do this one, right? Or
Yes, yes. For that also we can use it. It can be used for that also, but not only for that.
okay,
Hope you understand, right? So this is what zero copy clone. How this is how it is working. For other databases, though your 10 micro partitions are same, right? It will have 10 micro partitions separately for demo and demo one. But here for 9, it is common. So you can see the storage cost is reduced, right? So this is also one special. So other than this, we have a lot many features, right? So this is about the Snowflake features. So now I want to show you something about how to load the data, how easy we can load the data into Snowflake tables, and how can we use the staging concept kind of things. So for time being, I have already written the script. I'm just going to explain you. So one thing I want to show, whenever you are creating any database in the Snowflake, right, by default, you will get the schema, information schema. So which have actually all the metadata informations. I told you, right, 99% of Snowflake features works based on the metadata. So Snowflake is very powerful and very keen on maintaining the metadata information. So for that, whenever you are creating any database, right, so by default you will get the schema and that it will maintain a lot many metadata information. See, for example, what are the tables available in that particular database and the information about each table, right? How, what are the columns we have and what is the type and count, everything. So just an example I'm telling you, right? Okay. So now coming to this loading part. So this is actually environment for Snowflake, right? So in Google, if you search for Snowflake free trial, okay, so Snowflake is offering you free travel with 30-day validation, right, and $400. Right, it's simple to register, right? So it will ask for just your name and your company name, company details. That's all, right? So if you complete that, you will receive a mail to activate, right? So once the activation is done, your account will get activated, right? So in Snowflake, what is the other special thing is for every user, it creates a separate URL. Okay. For example, if you take maybe AWS or Azure, right? If you are availing the cloud, right? So the URL will be same, right? But our credential will be different. But for Snowflake, the URL itself will be different. See, you can see, right? So this is the URL for me, right? So if you are creating your account, you will get a unique URL. Okay, so what the URL is having is this is your account name, right? Then from which location you are availing the service and which cloud platform. Okay, so I have taken the Snowflake service from AWS and my location is Central, Canada Central, and this is my account. Okay, so when I click this information, you can see this is my account. Okay, so what I'm trying to say is you should not miss this URL. If you miss this URL, you cannot log into your what Snowflake thing. You cannot avail it. Okay, so that's one thing. So this is the cloud platform. I think it's simple. Here is your editor. This is your navigator. It shows what are the databases and tables, objects, everything it will show here. And you can create your own worksheet. Okay, so where you will type your SQL scripts and you can run it. Okay, and this side you can choose your role, right? So by default, Snowflake is having 5 different roles, right? So I don't want to get into very deep here. So here, if you choose, you can see what are the databases available. If you go to particular database, right, it will show you what are the tables, views, schemas, everything. So Snowflake is even user friendly also, like in terms of user interface, right? So if you take like if you take a SQL Server, right? So if you want to see what are the tables and views are available, you'll have just this navigator alone in the left side, right? So even in Snowflake, it provides this type of things also, right? So it is very, in terms of user interface, it's very user friendly, right? So if you click on this particular table, it will list out what are the columns we have and type this. In this way also you can see it. Schemas, everything. So here you can see the option load table, right? So this is also internet staging concept, right? If you want to load the data into a table, that you need not write any query also. Okay, you can just use a user interface to load your table. So how to do that? Uh, if you want to load a particular table, go to the corresponding database, get into the database, choose the particular table, right? Then here you will be having the option load table. Click on it. Then it will ask for which warehouse you want to choose. I told you warehouse means a group of processes. Okay, so you can create your own warehouse, right? Means because the workload of mine and you will be different. Okay, so based on your workload, you can choose the warehouse size. Okay, so Snowflake is offering different sizes of warehouses, like starting from extra small to extra large. Okay, so based on your workload, right, you can choose the warehouse. Okay, so you can create your own warehouse. So if you go here, this is warehouse. You can create it. While creating, it will show you different what is the size of warehouse you want, and based on your size, the credit. Snowflake is charging based on the credit, right? Not based on the dollars or cost, right? So it is purely based on credit, right? So if you are using this extra small warehouse for 1 hour, right, it charges 1 credit. Okay, so it's similarly based on your sizes. Okay, so first thing is you have to create a warehouse because it is responsible for executing the query, right? If there is no warehouse, first you have to create it. So as of now, I have one warehouse with this size. Okay, so now coming to low part, you can see it is not that you can have every user can have only one warehouse. It is not like that. You can create n number of warehouses with different sizes. Okay, and whenever you are doing any operations, like whenever you are executing any query, right, based on the complexity of your query which you are going to execute, you can choose the warehouse. Okay, so for example, if you are executing a simple query, you can choose a small warehouse. If you are executing a complex query with different number of joins and the things, then you can opt for, I mean, you can choose extra large, 5 extra large kind of things. So by this, by this options also, Snowflake is supporting you to reduce the computing cost, because as I told you, if the extra small warehouse is running for 1 hour, you have to pay 1 credit. Okay, so that's all. It's a lot many things to explain, but just a shortcut. So first you have to choose the warehouse. Okay, then give next. Then here you can choose your files from your system. See, I have my files here. From your local disk, you can choose the things. So just the file I want to load. You can just choose, give upload. Okay. So next is the file format. You know, right? So there is a concept of file format, which actually what that actually used for aligning your data. Aligning means what type of data you want to load and what is the size and what should be happening if the error comes. So, so that information you can give it in your file format. So as of now, I don't have any file format. So if I want to create, I can just go and create it by clicking this plus. So I can give the name for the file format. So what is the purpose of the file format? As I already told you, it is used for aligning the data load. Okay. So see the option, what type of file you want to load. Okay. So that you can choose. As I already said, it is actually supporting both your structured and semi-structured files also. Okay. So that what type of file you can choose it. Then compression method, I told you, right? Whenever you are loading your data into a table, your Snowflake will actually compress the data, right? So a lot of compression algorithms are there. By default, it will use this gzip. Okay, then you can specify in my file how the data is getting separated. You know, right? Since it is CSV, you can choose either command, tab, something like that. So this actually describes your how your input file is. Okay, it gives the information about your input file. Okay, and what is the row separator? How is there any header or not? If there is a header, you can specify how many lines of headers you want to skip, and especially if my data is enclosed by something like single quotes, double quotes, that also you can specify, and escape characters you can specify, and what happens if the error comes, that also you can specify. See, that may be the chance of having uh, unqualified data also, right? In that case, what the Snowflake processor has to do, whether it has to reject that record, that particular record, or it has to reject the whole data load, that also you can choose in the next thing. So you have to create your file format. Okay. So once the file format is chosen, then you can specify, as I already told you, what happens if the error is encountered. Okay. So whether I should stop whole loading and revoke, this is the default thing, because you know, right, whenever you're doing a transaction, it has to be 100% completed, right? If there is any error, it has to be stopped and rollback has to be done, right? So otherwise, what whether I should continue, these things I can choose, and I can just give low. So now I don't have any file format, so I'm not choosing this. So this option also, this user interface option also available to load your data instead of writing a query, sitting and writing the query, right? But as a developer, we are sticking on to the table, I mean, query, right? So that's what I'm telling. So already the table is there. So what I'm just doing is I'm just undropping the table. Sorry, I'm dropping the table. So one thing you have to note down, in the right side, right, you have the option to choose the role in on which role I want to execute this query. So that role you can choose, right, by changing this. Okay, right. Then you can choose your warehouse. You which warehouse the Snowflake should use to execute this statement. I mean the query I'm writing in this worksheet. Okay. Then which database on which database and which schema this query has to execute. So that thing I can choose it. Okay, and it differs for every worksheet. You can see, right? For this worksheet, I'm choosing this demo public, and when it goes to other worksheet, you can choose your own. I mean, different warehouses, databases, and schema. So you see that there is one circle here, right? So this is used for checking whether my warehouse is currently on or off, right? You know, whenever the warehouse is on, you have to pay for it because the in the background the warehouse is doing some execution. So obviously there's some computation is going on. So for that you have to pay, right? As of now, this warehouse is off. Okay, so when you're executing a query, you will that this is DDL, so that is not a problem. So I dropped it. So I'm recreating the table in this demo and public schema. And this table is having these columns that you can understand. Okay, even you can see that still this warehouse is off. Okay, to execute your DDL, the warehouse is not required, right? It is not doing any computation there. Okay, so now I'm showing you the table is empty. Okay, so now I'm having your files here in my local machine. So I'm going to show you how to load the data available in this file into this particular table. Okay, so one thing I showed you how to do it with the user interface. So now I'm going to show you how to load this with the query, SQL query, right? Right. So now table is created, right? So now what I have to do is I have to move all these files available in my local machine into the staging, right? I told you, right, already, whenever you are loading any data in Snowflake, will use a staging concept. Okay. So when you are using this user interface, what actually happening is it moves all the files, whatever files selected here, right? It moves. Whenever I'm selecting all these files here, what happens is it moves all the files from your local machine to the internal staging of the Snowflake. Okay, right? This is happening. So the same step, if you want to do in a SQL, what you have to do is you need to use this NoSQL. There is a uh, SnowSQL thing. Okay, right? So you have to install that the NoSQL into your local machine. This is acting as CLI. Okay, this is acting as the intermediate between your Snowflake interface and your local machine. Okay, you want to move, right? So that's what. So for this, what you have to do is use open your terminal. You have to use the Snowflake, SnowSQL command with sudo. Then you have to use -a. A lot of things are there. -a means you want to connect with the Snowflake account, right? So -a, then you have to choose your, you have to give your account. So I told you three things differs your account with others account is your account name, then your location, then the service provider. So you have to copy this from your URL and you have to give it here. So sudo user snowsql command -a means A stands for account. So then account name. So it is asking for my sudo user password. Now it is getting connected. Once the connection is established, it will ask for the username and password. So username password, this is your Snowflake username password. So which you are giving here to log in. Okay. So once you get this, your username with what is your warehouse. Okay. So now you understand what is the use of SnowSQL. This is used to create a connection, used to establish the connection between your local machine to your Snowflake cloud. Okay, so that what is the purpose of this connection is to move your files, to transfer your files from your local machine to the that particular cloud. Okay, like so now choose on which database you want to work using this command. So I want to work with demo database. So hope you can see here, right? I want to work with the demo database. So I'm just giving use database demo. Sorry, typo error. So now so when you are executing this, you can see here, right? Initially that is no database, but once you are chosen, you get the database name here dot schema name. So by default, it will choose the public schema. Okay. So in case if you have any other schema in your database, you can create as many number of schemas you want. Okay. If you want to choose schema, particular schema, you can just again use schema, then schema name. Okay. So now I want to work with public only. So I can just give it. Okay. So now everything is selected properly. Now what should I do is I have to execute some command to transfer my files from local to Snowflake, cloud, internal staging. So for that, you have to use this command, put command. Okay. So put file : / put file : so since I'm using Mac, you know well, right? It is having /. Then I have to specify the path of my files. Okay, so where my files are available. So my files are available here. So you have to specify the path here. Okay, so I'm just specifying the path. Okay. So you can see I have 5 files here. And if you see the name of the files, it is employees 01, employees 02, employees 03, like 05. Okay, right? If you are just specifying like this, it will load only the files end with 01, right? In case if you want to load all the files with the same pattern name, if the pattern of the names are same, you can use the pattern to load your files. So you know well, right? Star means whatever characters we have in that file name, all the files of the same pattern will get loaded. Okay, so put file : path of your file. Okay, so now I specified where actually my file is available. Next, I should specify where actually these files has to be moved. Okay. So where I want to move is, I want to move to the internal stage of Snowflake. Okay. So, internal stage, actually there are three types of internal stage in Snowflake. Okay. So I don't have time to explain all the things. So one is the table stage. Okay. So whenever you are creating a table in Snowflake, for every table, Snowflake will create one internal stage. Okay. So when I'm executing the create statement here for this employee EMP basic one table, it creates its own internal stage. Okay. That is called table stage. So here that is called table stage. So I want to move these files to that table stage. So how to specify that? I have to specify, I have to use the at symbol, and I have to give the fully qualified path, means your database name, then your schema name. Then to mention that as an internal stage, I have to use this percentage. Okay. Then I have to specify the table. So name of the stage area, name of the stage area and the table name will be same. Okay. So that's what I'm giving, EMP underscore basic underscore one. So when I hit enter, you can see all the files are loaded here. So you can see what is the size and what is the status of your upload. So once it is done, now all the files are moved from your local machine to Snowflake internal stage. Now the files are available in internal stage. Now from that internal stage, the data has to be moved to the particular table. So for that, you have to execute this copy command. Okay, so this copy command is used for loading data from staging area to your corresponding table. Okay, so what is the syntax is copy into which table you want to load. So the table name, so I'm giving the fully qualified path, right? Fully qualified table name, demo.talk, right? The thing from where you have to take the file. So obviously it is in the staging, internal staging, right? So that internal staging name I should specify. Okay. Then obviously I should specify the format of the files I want to load, right? So for that, if already the file format is there, you can just specify the file format name here, right? Already you have created some file format, means you can just specify the file format name here. So far there is no file format here I have created here. So I'm I'm specifying what type of file I want to access, and is there any optionally enclosed things. Okay, and then what are the your staging area may have n number of files, right? Right. From what are the files you want to load the data, right? So you can specify the if you know the file names, you can specify the file names here with the help of the files property. Within single quotes, you can specify what are the files you want to load. Okay. Otherwise, you can use this property, pattern property, if your file names are having some pattern. So here, my file names are having some pattern, right? So every file names, it's having employees, then have some zero, then some numbers from 1 to 5, and all are CSV. And one thing you have to note down here, after loading a table into internal stage, you can see there is some GZ in my this thing, right? So I told you, right? So it is compressed and it is using that gzip algorithm by default. So that's why you get this gz. So this is your source and this is one. So basically, this is the content I'm planning to cover. Okay. So clustering things, how to load and how to unload, and how to work with semi-structured and Snowflake. Since you all are from database background, right? So I think you are having good knowledge on SQL, right? That's more than enough to get into this. Okay. So only thing is we'll use some special comments for each and every features. Okay. So these are the topics. Maybe I will share this document with you. So these are the topics I'm planning to cover in this course. Okay, almost all the features: time travel, how time travel is working, fail safe, and zero copy clone, and how to work with data sharing, and these kind of things. And
Uh,
since you're familiar with SQL already, I'm planning to complete this with 30 hours. Again, based on the speed the people are learning, right? We can fix them. But 30 hours is more than enough.
Sure, Prem. And one question is like, will you be able to give some documentation apart from the Snowflake documentation which is available online? Can you give us some sort of cheat sheet sort of things to just for the sake of overview? Will you be covering? Will you be able to provide that information too?
So I think that's all from my end. The only thing I can show is you can see, right? So after executing this, the table gets loaded. So the result of this command, it shows you what other files are loaded and how many records are passed, and is there any error, this kind of things. And you can see that data is loaded. So this is how your staging is working. So that's it from my end.